Welcome back everyone, and in today's video we are going to learn about the basic proportionality theorem, or which is known as the Thales theorem. So let's read first the statement to understand. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So let's do this by drawing a figure. Okay, so let us consider a triangle ABC. So let A, B, C be a triangle. And suppose let us draw a line which is parallel to the side BC. So let us draw a line which is parallel to the side BC such that it intersects the side AB at point D and intersect the side AC at point E. So DE is parallel to BC. So that is the given part of this theorem. Okay, so yeah, let's write first the given part. Given triangle ABC and line DE is parallel to line BC. Okay, so to this triangle ADE, first, let us concentrate on this triangle ADE. We can draw two perpendiculars from the point D and the point E. So from the point D, let us drop a perpendicular on the side AC or on the side AE. And from the point E, let us drop another perpendicular let us say this one is DF and EG. So EG is a perpendicular on AB along the side AB, and DF is a perpendicular along the side DC. So that will be in the construction. So construction, perpendiculars EG and DF are drawn on sides. So EG is drawn on side AB, are drawn on sides AB and AC respectively. Okay, so here let us write first the area of triangle ADE. Now this is the triangle ADE. Area of triangle ADE. And as we all know that the area of a triangle is given by half base into height. So if you consider this triangle ADE, as we can see here, there are two perpendiculars or two heights. If we consider EG as the height, then AD will be the base, and if you consider DF as the height, then AE will be the base. So let's write both of them, the area of both of them. So area of triangle ADE is equal to half base. So the base, let us consider AE. So if you consider the base as AE, the height will be DF. So DF. Let's note this as equation 1. Or we can write as area of triangle ADE is equal to half into base. And now let us consider AD to be the base, AD into, and let us consider, if AD is the base, then EG will obviously be the perpendicular. Okay, so those are the two areas of triangle AD. Even though the height and the base are different, but we must keep in mind here that the area of both these triangles are the same, since we are considering the same triangle ADE. Okay, so now what we are going to do, let us join BE and CD. Join it, BE and CD. Okay, so one line should be there. Okay, CD and B. So if you consider this triangle BDE, this triangle BDE, so from triangle BDE, area of triangle BDE equal the same thing. So if you consider this triangle BDE, then obviously EG will be the perpendicular, since this EG falls on the line along BD. So if EG is perpendicular, then BD will be the base. So half base is BD, height is EG. Let's note that as equation number 3. And the area of the triangle, not BDE, but now let us consider CDE. Let us consider area of triangle CDE is equal to half into base. Similarly, like we have considered for BDE, let us consider the base CE, and if CE is the base, then along this base DF is the perpendicular. So half into CE into DF. So that will be the area of the triangle CDE. And let's name this one as equation 4. Okay, as we can see here, these two triangles BDE and the triangle CDE, are between the two parallel lines. And they share the same base DE. So they must be equal. Since BDE, triangle BDE and CDE are between the two parallel lines DE and PC, and they share the same base DE, triangle BDE and triangle CDE must be equal. Okay, so since triangle CDE and triangle BDE are in between two parallel lines, and share the same base. Therefore, area triangle CDE is equal to area triangle BDE. And we all know that the area of triangle CDE from equation 4, area of triangle CDE will be half into CE into DF. So half into CE into DF is equal to area of triangle BDE. So area of triangle BDE will be half into BD into EG. Okay, so let's move on again from this line here. So what we are going to do, we are going to divide both sides of this equation by the area of a triangle. So let us divide both sides by the area of triangle. So half EC into DF is equal to half into BD into EG divided by area of triangle ADE is equal to area triangle ADE. Okay, so I think we understand here, if we divide both sides by area of triangle ADE, it has no effect on the equation since both the areas are equal. Now we can use from equation 1 and equation 2. So instead of writing the area of triangle ADE, instead of writing area of triangle ADE, we are going to write from the previous equations that we got, half into base, so half into AE into DF, half into AE into DF. And similarly on the right side from the other equation, that both of them are from equation 1 and 2, we can write as half into AD into EG, half into AD into EG. So as we can see here, this half and half can be cancelled out, and similarly DF and DF is the perpendicular, EG and EG is also the perpendicular. So what we are going to left is, we have EC by AE is equal to BD by AD, or we can write as AD by BD is equal to AE by EC. Here we get by cross multiplication, just exchange the values, the denominator and the numerator and numerator. So what do we have? AD by BD, as we can see here, AD by BD is equal to AE by EC. So if we have this equation, what can we say? We can say that this line DE, which is parallel to the line BC, divides AB and AC in the same ratio. So that is the basic proportionality here. If we get that, so hence line DE divides AB and AC in the same ratio. So that is the basic proportionality theorem. So that is what we have learned in today's class. So if you have any question, any doubt, or anything that you want to comment, please drop it in the comments below, and make sure like, share and subscribe. Until next time, God bless you and stay safe.